Hi everyone. So today is Wednesday, October 5th. Uh, we are one lecture behind schedule, okay? So today we'll talk about 3.7 and then maybe Friday we'll talk about 1.7, okay? So because we are a little bit behind schedule, so that means we might not be able to cover all examples in class worksheets. But we can cover some of them, so I will make sure to cover all the possible types of problems. And then there are some like extra problems you can practice at home. And don't forget online on our course website, the notes with the answers has all the answer of the examples. So if we cannot cover all of them, you can work the remaining at home and then check your answer with the solution online. Is that clear, everybody? Mm-hmm. Yeah, I really need your help to catch up. Because our course is the prerequisite of Calculus 1 and other course, right? Major courses. So that's why we have to cover all the class objects. Okay, so we cannot miss some. So yeah. So hopefully with the recordings, you can review the recordings, and when you play the recordings, you can control the speed, right? You can pause at every step to think through the math. So, and please feel free to come to see me in my office hours, or if you're not available during my office hours, send me an email, okay? Yeah, class time, we have limits, so we have to catch up schedule. But if you come to my office, I'm happy to go over the problems with your speed to make sure you understand every step. Okay, everybody? So come to my office hours. All right. So this week we do not have any quiz, but please keep doing your homework, right? Doing it weekly, and don't forget the previous homework. You can do it multiple times to increase your score. If you have some questions, feel free to ask me. Okay, everybody? Mm-hmm. All right. So 3.7. Okay, so rational functions. A rational function is a polynomial over a polynomial. So we have p of x over q of x. And here are some examples. The first one. So we have x over x minus 2. And do you remember how we find the domain? So when we find the domain, we look at, oh, do we have square roots? If yes, then we need the things inside the square root to be greater or equal to 0. Right? Yes, everybody? And second one, if we have fraction, we need the denominator not equal to 0. Right? Do you remember that when we find the domain? Yes. So look at this function, x over x minus 2. So we have fraction. We need the denominator not equal to 0. So denominator, x minus 2, not equal to 0, right? And so that's the domain. Then we can add 2 on both sides. We get x not equal to 2. X not equal to 2. So do you see x equal to 2 is this number? Okay? So x not equal to 2 means this vertical line. Okay? The function cannot touch this vertical line. So usually for point, we use solid circle, okay? To indicate the point is right here. And we use open circle, okay? Open circle to indicate the point is missing. But for line or curve, we use solid line to indicate the line is there or the curve. But we use dashed line to indicate that is missing, okay? So here we want to make sure this is the domain. X cannot be 2. So you can use a dashed line to indicate x cannot be 2. Okay, everybody? And you can see this is the graph of the this function, and you can see when x is going closer to 2, the y either goes to infinity or y goes to minus infinity. We never touch this line. Do you see that, everybody? Okay, how about this one? This is a rational function, right? To find the domain, we set the denominator cannot be 0. So find domain, we set the denominator cannot be 0. And then we try to find the roots. You see, oh, okay, what's the discriminant? B squared minus 4ac. B is the coefficient of x, which is 1, right? And minus 4ac. Do you see a is 1, c is also 1? So the discriminant is 1 minus 4 times 1 times 1, which is 1 minus 4, negative 3. Do you see that is negative? What does that mean? Okay, we call quadratic equation. If the discriminant is positive, we have 2 real roots, right? If discriminant is 0, we have 1 real root. If discriminant is negative, we have no real roots. Oh, it's negative, so no real root. Okay, so no real root. Therefore, this guy is not equal to 0 for all x. So domain is all real numbers. Okay, so domain in this case is all real numbers. Or you can use this notation, minus infinity to positive infinity. Okay, that's the domain. And our previous problem, so you can write the domain minus infinity to 2, not including the 2. Okay, so parentheses, and 2 to infinity. Questions? No. Okay, so we're solving this guy not equal to 0, right? And in general, we have the quadratic function y equals a x squared plus bx plus c. And it depends on the discriminants. If it's positive, then our picture looks like this. We have 2 roots. Okay, we have 2 roots, R1 and R2. Okay, those are the 2 roots. If we have the discriminant is 0, then we have 1 root. Okay, it just touched the x-axis. So we have 1 root. And then if the discriminant is negative, then we have the parabola lies entirely above the x-axis. Okay, and here we're talking about, well, we need this guy is not 0. Can it be 0? We look at the discriminants. Because it's negative, we don't have a root, no real roots. So this guy cannot be 0. And actually, you can look at this picture. This guy is always positive. Okay, so it's always positive. That's why the denominator is positive. That's okay. As long as the denominator is not 0, then we're okay, right? So that's why the domain is all real numbers. Maybe it's better to look at this example as well. This is a quadratic factor in the denominator. So we do the same thing. We have the domain, which is the denominator, x squared minus 5x minus 6. It's not equal to 0. But for this one, do you see? We can factor it, right? How can you factor it? Minus 6 and 1, right? So x minus 6 is not 0, and x plus 1 is not 0. We have x not equal to 6, and x not equal to negative 1. Very good. See? we have two roots, right? X cannot be 6. See, 6 is right here. So you can put a dashed line here to indicate x is never equal to 6. And x is not equal to -1. So we have another line here. Okay? So this guy corresponds to here. See, we have two real roots. So those roots, x cannot be those two numbers. And how do you write the domain? Well, you say what? Minus infinity up to -1 and union. -1 up to 6 union 6 to infinity. That's the domain. Right, everybody? Okay, very good. Okay. So most of the time, rational functions have vertical asymptotes and a horizontal asymptote. An asymptote is basically a line or a curve to which the graph of the function get closer and closer. So usually here, see, here we have the vertical asymptote x equals to 2 because the graph, the function is getting closer and closer to it, right? But it never touches. Okay, and here, do we have a vertical asymptote? No, right? Here, do we have vertical asymptote? Yes. X equals to -1, and this line, this vertical line, x equals to 6. So we have two vertical asymptotes here. So yeah, usually there are 4 ways a function may behave near vertical asymptotes. And here are the 4 functions. Okay. All right. Hey, where's my graph? It's disappeared. Interesting. Okay, it's disappeared. So, okay, let's use this one. So this is our course website. Remember, all the blank notes are on our course website, and this is 3.7. So this is the blank notes, and this is the notes with answers. And let's see. It's good that you print out the notes and bring to class. Then you don't need to copy everything, right? The picture, you don't need to copy them. You don't need to copy it. You just need to take small notes. Okay, so this is the 4 picture. Okay, vertical asymptotes. Look at this picture. Do you see, this is the blue curve is the function. Okay, do you see the function is getting closer, closer, closer to the vertical line? Yes, everybody? And you can think of, okay, this is our x. X is approaching this A from the left. So we use the notation A minus to indicate X is approaching A from the left. Okay, everybody? Because left is more negative. Right is more positive, right? So if you want to indicate, oh, approaching it from the left, you use A minus, and you put the minus on the exponents. So that's the notation. Okay, and because the y goes to up there is infinity. And if the y goes down, down is minus infinity. So here, left, top, approaching from the left and go to the top. This is x goes to a from the left, so a minus. Y goes to infinity. Here, from the left, and go to the bottom. So as a approaching, as x approaching a from the left, y goes to minus infinity. Or we can have on the right side, see? X approaching A from the right. So the notation, A to the positive. And then if y goes up, that's infinity. If y goes down, that is minus infinity. Is that okay, everybody? So this side, we say x goes to A from the left, y goes to infinity. How about here? X goes to A from the right. Y goes to negative infinity. Yes, we can have one of those 4 ways. Very good. Okay, we keep going. So for rational functions, vertical asymptotes happen where the denominator is 0. Okay, so let's see. Example. Oh, thank you. Find the vertical asymptotes of the following functions. For each vertical asymptote, determine what happened to y as x approaches from the left and from the right. Okay, so that means that the y goes to infinity or minus infinity. Okay, so first steps, we find the domain. Okay, so domain is you set the denominator cannot be 0. Okay, and in this case, do you see we subtract 2 on both sides? We get x cannot be negative 2. Yes, everybody? Okay, and then, okay, so we have the number negative 2. Okay, so we want to let x approaching negative 2 from the left and from the right and see what happened to the y. Okay, so let me write here so I have more space. So let x goes to negative 2 from the right. From the right, that means x is bigger than negative 2. Do you agree? So this is negative 2. X approaching it from the right. So x is bigger than negative 2. Do you agree, everybody? So look at this factor, x plus 2. So if you add 2 on both sides, you get x plus 2 is greater than 0. Do you agree? So we have x plus 2 goes to 0. But because it's bigger than 0, so that's why it's approaching 0 from the right. Is that okay, everybody? Yeah? If x goes to negative 2 from the right, then the factor x plus 2 will go to 0 from the right. Yes. Okay. Now, what is the y? The y will go to, you try to plug in x equals to negative 2 inside here. Okay? When you plug in x is negative 2, do you see the numerator? We get negative 2 minus 1. And the denominator, we get negative 2 because x goes to negative 2 from the right. Okay? So x, and so you replace x by negative 2 from the right, and then you add 2. Do you see this guy is 0 plus? And the numerator, what's minus 2 minus 1? Negative 3. Okay, what is this? Well, if you see a number over 0, this is undefined. Yeah, everybody? So if we see 0 in the denominator, that's undefined. But what is 1 over 0 plus? Infinity, very good. So how do we think? 0 plus is a small number, a number that is getting close to 0, and it is positive. So you can think of 0.001. 1 over 0.001 is 1,000. Yes, everybody? So 1 over a very small positive number, we get a big number. That's why, if that number is smaller in the denominator, you end up getting bigger number. So that's why infinity. And how about 1 over 0 minus? Yeah, very good. If you put a minus sign here, this guy becomes negative. So that's why we have minus infinity. So here, what do you think? Minus 3 over 0 plus is, you can think of this as minus 3 times 1 over 0 plus. 1 over 0 plus goes to infinity, right? But you multiply by a negative number. So this becomes negative infinity. Okay, everybody? So you actually count. So constant over 0 plus or 0 minus is infinity. But is it positive infinity or minus infinity? You look at how many negative signs are there. So if we only have one negative sign, that is minus infinity, right? If we have two negative signs, then we get positive infinity. Right, exactly. Good. Okay, so we have the y goes to minus infinity. And then next one, we also need to check what happens if we let x goes to negative 2 from the left. Okay, so if you get used to this, then you don't need to write it down, okay? So x goes to negative 2 from the left, then the factor x plus 2, it goes to 0 from the left. That's always the case, right, everybody? Okay, now what happened to our y? So x goes to negative 2, so the numerator, we still have negative 2 minus 1, but the denominator, we get, you can see, x plus 2, it goes to 0 minus. Yeah, so we get negative 3 over 0 minus, and what is that? Infinity, very good, because we have two negative signs. So that makes it positive infinity. And therefore, we have the vertical asymptote. So vertical asymptote is the line x equals negative 2. Okay? Typical mistake is students would say vertical asymptote is negative 2. No. Vertical asymptote is a line. So for a line, you need an equation. So x equals negative 2. Okay, not just the number negative 2. And we can also draw the picture, right? We can draw the picture, so what it looks like. Negative 2 right here. So this is the vertical asymptote. And when x goes to negative 2 from the right, the y goes to minus infinity, right? So that's why the picture like this. See, we're approaching from the right, the y goes down, yeah? And when we approach negative 2 from the left, the y goes to infinity. So it goes up. So this is the picture, what it looks like near the negative 2. So far, so good, everybody? Awesome. So let's continue. Let's look at this example. So this example is a harder example. Okay, so first thing we do is to factor it. Okay, so this guy, the first step, factor it. How can we factor it? Yeah, 3x squared. The factors are 3x and x. What are the factors of minus 1? 1 and negative 1. Where do you put the 1? And where do you put the minus 1? This guy should be positive 1. This guy should be negative 1. Very good. So this is plus 1. This is minus 1. Okay. That's the numerator. How about denominator? So we have factors of 2x squared. There are 2x and x. What are factors of negative 2? 1 and negative 2 or negative 1 and 2, right? So how do we get 3? We need negative 2 And 2, we need 2, and then -1, right, everybody? So we put 2 here, and we have -1. Then 2 times 2x is 4x, and then -1 times x is -x. When you add them up, you get 3x. Right, everybody? So this is how we factor it. And then we can continue with the step we have before, right? So now we find the domain. To find the domain, do we look at the numerator? No, we only look at the denominator. So the denominator, 2x minus 1, x plus 2, cannot be 0. Then each factor cannot be 0. Okay, so x is not equal to what number? Yeah? 1/2. Good. And here, x not equal to -2. Oh, do you see? We have 2 numbers. So we need to check for 2 numbers, and each number we need to check the left, the right, right? The left and right. So we need to check 4 things. Okay, so this problem is harder than the previous problem. Okay, let's check the integer first. Okay, so x goes to -2 from the right. So I usually check it from the right first, and then I check from the left. Okay, so yeah, this is the first step we check. Okay, so if x goes to -2 from the right, do you see this corresponds to the factor x plus 2? Yeah, so you have x plus 2 goes to what? 0 from the right. Yes, everybody? You see the roots, and then the factor it corresponds to it. So the factor will go to 0. Now, how about our y? Okay, so to find the y, do you plug in here or in the factor form? Which way we should plug it? Here, the left, or the factor form? The factor form. Yes, very good. So the typical mistake is didn't plug in the original function. No, make sure we plug in the factor form. Okay, so plug in the factor form. We plug in x is -2. So see here, 3 times -2. What's 3 times -2? -6, right? Plus 1. And then x is -2. -2 minus 1. And then what's 2 times -2? Negative 2 times -2? 4 minus 1. Yes, everybody? We're putting in this one. Oh, what's x plus 2? Goes to 0 plus. So far, so good, everybody? Yeah, we plug in x is -2 for all the x expressions. And let's simplify. What's -6 plus 1? -5. -2 minus 1? -3. -4 minus 1? -5. And 0 plus. Do you see -5 cancel? Yes? What is -3 over 0 plus? Infinity, but negative, right? So constant over 0 plus or 0 minus, we're going to get infinity. But plus infinity or minus infinity, you count how many negative signs. If you have an odd number of negative sign, then you have negative infinity. If you have an even number of negative signs, you get positive infinity. Yes, very good. Okay, now we keep going. So when x goes to -2 from the left, x plus 2 will go to 0 minus. Okay, so you don't need to do the same thing again, because what compared to the previous line, what is gonna change? Do you see you still plug in x is -2? So this one will stay the same, this one will stay the same, this one will stay the same. The only changes is you replace this plus sign by minus sign. Yes, everybody, that is the only change. So, okay, at this step, it will be almost the same, but you replace the plus sign by minus sign. Do you see that, everybody? Yes? So, you don't need to write those down. You just put arrow. It's too long, sorry. Too long. Okay, right here. So, we have -3 over 0 minus. So, what is the answer? Infinity. Yes, very good. So it can save you some work. Okay, so that's why you always do the plus first, and then the minus. You just change the 0 plus to 0 minus. Okay. All right. Next. So we might have some questions. Can we just skip this step and change the sign here to get minus, to change the minus infinity to plus infinity? No, we cannot do that. Why? For this example, because because this guy, the power is 1, okay? So the answer will flip the sign. But for another example, okay, so if I have another example, if we have this guy is square, then you end up getting this guy square. So this guy square, this guy square. Do you see 0 plus square is still 0 plus? But 0 minus square becomes 0 plus. Okay, everybody? So if we have a square here, you actually end up getting the same thing. You get minus infinity. Okay? So you can only go to this step, replace the 0 plus to 0 minus. But then this step, you look at, okay, if this guy, we only have like this guy raised to the power, you will preserve, you will have the, okay, so if this power is an even power, then your answer will be the same. But if this power is an odd power, then your answer will be opposite of that. Is that okay, everybody? Yeah, so we have to be careful. Okay, so let me erase those. Okay, now let's keep going. So x goes to 1/2 from the right. 1/2 corresponds to the factor 2x minus 1. So 2x minus 1 will go to 0 plus. Is that okay, everybody? Okay, the y goes to, now we plug the 1/2 into the factor form, right? So 3 times 1/2 is 3/2, and plus 1, and 1/2 minus 1, right? And do you see this 2x minus 1? This factor goes to 0 plus. Times what? This is 1/2 plus 2. So far, so good, everybody? Okay, keep going. Oops, sorry. Sometimes my hand just touch the bottom by mistake. Okay. What's 3/2 plus 1? 5/2, right? 1/2 minus 1? Negative 1/2. And 0 plus 1/2 plus 2. Is it 5/2? Oh, what's your answer? Negative infinity. Very good. Okay. And now, last one, when x goes to 1/2 from the left, 2x minus 1 goes to what? 0 minus, then the y goes to, do you see? We get minus 1/2, but over 0 minus. That is infinity. Yes, everybody? 2 negative signs. So make it positive. Great. So, therefore, vertical asymptotes are the line x equals to -2 and x equals 1/2. So we have 2 vertical asymptotes in this case. So far, so good, everybody? Okay, so this is how we find the vertical asymptotes. We first check the domain, and then for each number outside of the domain, we check the when we're approaching it from the right, what happens? When we're approaching it from the left, what happens? Okay, so if your y goes to infinity or minus infinity, then those lines are vertical asymptotes. Okay, awesome. Any questions about this problem? Are we all good? Yes. So the practice, I will leave it to I will let you to do at home. Okay. So our websites. So see our websites. I have the answer for it. So after you finish, you can check the answers. Okay. But because we are behind schedule, we cannot go over all the examples in class. So okay. Now, so that was vertical asymptotes. Now let's talk about horizontal asymptotes. So horizontal, so that's why they are horizontal lines. Horizontal asymptotes happens if x goes to an and y goes to a number. See? This number is b. See, y is approaching to this horizontal line, y equals b. Or we can have x goes to minus infinity, that's the left hand side, right? And y goes to b. So this is a horizontal line, y equals b. Okay. So horizontal asymptotes of function can only have at most 2 horizontal asymptotes. One is from the left, and the other one is from the right. Okay? Vertical asymptotes, you can have as many as you like, right? But horizontal asymptotes, just at most 2. Okay, everybody? All right. Okay. So, given the rational functions, what is the horizontal asymptotes? Okay. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is 0. Okay, how do we think? You know 1 over infinity is 0. Is that okay, everybody? Because 1 over a big number, okay, let's say 1,000, you get 0.001. So 1 over a big number is a small number. Do you agree? And 1 over minus infinity. See, if you put minus, oh, this guy is also getting close to 0. Do you agree, everybody? Yeah, so if you put a minus sign here, and then this is minus, but this number is still going close to 0, right? So 1 over infinity is 0, 1 over minus infinity is also 0. And now, let's make some examples. So degree of the numerator is less than the degree of the denominator. You think about, okay, let's say degree of numerator is 1. Degree of denominator, 2, right? Okay. Do you see we can cancel one of the x? Yeah? Now, when x goes to infinity, do you see we get 1 over infinity? Yeah? Then the y goes to 0. 1 over infinity is 0. Okay, that's why if the degree of the numerator is less than the degree of the denominator, then we have a horizontal asymptote y equal to 0 because y goes to 0 as x goes to infinity. Is that okay, everybody? And if the degree of the numerator equals the degree of the denominator, then the horizontal asymptote is y equals to the leading coefficient of p and over the leading coefficient of q. Why is that? Well, you think about 3x squared over 4x squared. Let this be y. Okay? Then, do you see x squared cancel? X squared cancel, and you just get 3 over 4. Yes, everybody? So that's why if the numerator and denominator have the same power, well, you kind of just cancel them and you get 3 over 4 is the leading coefficient of P over the leading coefficient of Q. Okay. And if the degree of the numerator is bigger than the degree of the denominator, so our example is now, okay, degree of numerator is bigger than the degree of the denominator. This is an example. Do you see the 2 and x cancel? We have x. So when x goes to infinity, this goes to infinity. So therefore, we have no horizontal axis. So yeah, so those are the 3 cases. And try to use example to help you to think. Okay? I don't memorize it. I look at the example. Choose simple example, right? Degree of numerator less than degree of denominator. So you let your numerator be x, denominator be x squared. Then you get, oh, this goes to 0, right? And they have the same degree. Okay, you can think about the example, 3x squared and 4x squared. Or you can think of other example, maybe 2x and 5x, up to you, okay? Then you get the leading. And if the denominator, the numerator degree is bigger than the denominator, think about x squared and x, then the y goes to infinity, so we don't have horizontal asymptotes. Okay, now let's see how do we solve the problems. So here we want to find horizontal asymptotes. Do you remember how we find vertical asymptotes? We factor it first, right? And then we find the domain, right? And then we look at each number outside of the domain. We let x goes to the number from the left and from the right and see what happens to the y, right? Those are the vertical asymptotes. But for horizontal asymptotes, we don't factor it, okay? We look at the dominant terms. So, okay. So here we want to think about it. If x goes to infinity, right? So x is getting bigger, bigger, bigger. We look at the dominant terms. So think about it. If x is 100, well, 8x is 800. 5 is just 5. 800 is much bigger than 5, right? And look at the denominator. Oh, 100 squared is what? 10,000 times 5. This is 5,000. This is just 300. Do you think 5,000 is it 50,000? 50,000 is much bigger than 300, right? So that's why when x goes to infinity, you just need to look at the highest power term. Okay? The smaller terms is very, very small compared to the dominant term. Okay? So therefore, if we look at horizontal asymptote, we mean the x goes to infinity or minus infinity, then we just need to look at the dominant term of the numerator and denominator. Okay? So dominant term is the highest power term. All right. So that's why we say when x goes to infinity, the y is approximately equal to 8x over 5x squared. Is that okay, everybody? We just need to look at the dominant term. Forget about the lower terms. Okay. And, oh, what can we cancel? X. We can cancel a copy of x. We get 8 over 5x. Right? Now, let x goes to infinity. Then you have infinity right here. What is constant over infinity? 0. Yeah, remember? 1 over infinity. Sorry. Okay, it just shrink. Let me save it just in case. Okay, so 1 over infinity is 0. 1 over minus infinity is also 0. So that's why when x goes to infinity, the y goes to 0. Okay, everybody? How about when x goes to minus infinity? The y will goes to, see, x is minus infinity. You kind of replace x by negative infinity. But 1 over negative infinity is still 0. Is that okay, everybody? So constant over infinity or minus infinity, we get 0. Oh, so that means we have one horizontal asymptote. So the horizontal asymptote is horizontal line. So y equals the number is 0. Is that okay, everybody? The horizontal asymptote is the line. Y equals 0. Okay, everybody? All right. How about this one? You look at the dominant term. What's the dominant term of the numerator? 3x squared. Denominator? 2x squared. So when x goes to infinity, the y approximately equals to 3x squared over 2x squared, right? What can you cancel? X squared. Oh, do you get 3 over 2? Yes. So, right. That is the horizontal asymptote. Y equals 3 over 2. And do you see, because here we don't have an x. So when x goes to minus infinity, it's the same stuff. Right, everybody? So y also goes to 3/2. Okay, therefore, what do you say? Horizontal asymptote is y equals 3/2. Yes. Okay, very good. Okay, so keep going. This one, look at the dominant terms, the highest power term. So when x goes to infinity, y approximately by 6x cubed over 11x squared. What can you cancel? X squared. Oh, do you see we have 6x over 11? Oh, but then your x goes to infinity, right? Then what happens if you have infinity in the numerator? It's infinity! Exactly. How about when x goes to minus infinity? You plug in what? Yeah, you plug in minus infinity here. So your answer is negative infinity. Okay. So what does that mean? So this is if we want to draw the picture, okay? When x goes to infinity, y goes to infinity. So I don't know what your function look like here, but when x goes to infinity, the y goes to infinity. So like that, right? And when x goes to minus infinity, the y goes to minus infinity. Looks like that. Do we have a horizontal asymptote? No. So in this case, no horizontal asymptotes. Okay, so this is how we find horizontal asymptotes. So do you think finding vertical asymptote is easier or finding horizontal asymptote is easier? Horizontal asymptote is easier. Okay? So, but the method to find vertical asymptote and horizontal asymptote are different. So be careful. All right. So the practice I will let you to do at home and then check the answers with the solution on the website. Okay, finally we get to this one. So our goal is to graph rational functions. So in your exam, we learn how to graph polynomial functions. Remember, you find the x-intercept and then the y-intercept, and then you put those intercepts on the xy plane, and you look at the leading coefficients, right? If your leading coefficient is positive, you start with the upper left, no, upper right corner, right? If your leading coefficient is negative, you start with the lower right corner, and then based on the multiplicity is even, you bounce off. Multiplicity is odd, we cross to draw the graph of polynomial functions. Do you remember that? Okay, now let's graph rational functions. So here are the steps. Step 1, factor the numerator and denominator. Okay, so let's follow the step. We need a lot of space. Okay, so let me let me just yes, and we just do one example. So let's just do example 3. Okay, example 4 you do after class. Okay. So, oops. Hey, did I press it close by mistake? Okay, so 3.7. Eh? What's 3.7? Oh, right here. Okay, so yes, right here. Okay, so factor the numerator and denominator. So numerator, how can you factor it? 2x and x, and then plus 4 and minus 1, right? That will give us plus 8x and minus x. So we get 7x. Yes, everybody? How about the denominator? X minus 1 plus 2. Yes, very good. Okay, that's the first step. See, first step, we factor the numerator and denominator completely. Okay, second step, find the x-intercept. So x-intercept is you set the numerator be 0. Okay, x-intercept, set the numerator to be 0. So yeah, x-intercept, we set the numerator, which is 2x minus 1, x plus 4 equals 0. So a product of two factors equal to 0. That means one of the factor is 0. So we have this guy or this guy equal to 0. What's the x? 1/2 and -4, yes. And remember, x-intercepts are points. Okay, so we have x is 1/2. What is the y-coordinate? 0. Yes, very good. And -4 zeros. So these are the x-intercepts. And y-intercept, you said what number is 0? X is 0. So let's find what is f of 0. So f of 0, you can plug in this one and this one. Which one is easier? Factor form or the original form? You see? When you plug in x is 0, all the terms with the x are gone. Right? So plug in the original form. Okay, plug in here. What's the numerator? -4. Denominator? -2. Oh, what's that? 2. So what is the y-intercept? 0, 2. Yes? So y-intercept is, we plug in f of 0. So write it down. X-intercept, set the numerator equal to 0. Y-intercept, find what's f of 0. Okay. Good. Next, find vertical asymptote. So, I put them in the same step, so okay. So I put them in the same step. Now this is step 3, vertical asymptote. So to find vertical asymptote, we set the denominator to be 0. So x minus 1 and x plus 2 equal to 0. What do we get? X equals 1 or x equals -2. Okay? Alright. And we also need to find what happens if x goes to 1 from the right and when x goes to 1 from the left. Okay, so x goes to 1 from the right. This corresponds to the factor x minus 1. Right, everybody? So we have x minus 1 goes to what? 0 plus. Yes, everybody? 0 plus. Then what happened to y? Do we plug in the original form or the factor form? The factor form. Yes. Okay. Let me use a different color here so you can see. Plug in the factor form. We plug in x is 1, right? So x is 1. 2 times 1 minus 1 is... Okay, let's do it slowly. X is 1, so this is 2 minus 1, right? So, okay, 2 minus 1, and then 1 plus 4. Is that okay, everybody? How about x minus 1? It goes to 0 plus, and then 1 plus 2. Okay, what's 2 minus 1? 1. 1 plus 4, 5. And 0 plus 1 plus 2, 3. Oh, what's the answer? Positive infinity. Yes, everybody? Okay, if x goes to 1 from the right, x minus 1 goes to 0 minus, right? And do you see we have the same thing, but now is 0 minus. Okay, so, sorry. Times 3. So what do we get? Negative infinity. Very good. Okay, keep going. How about -2? So -2 corresponds to the factor x plus 2. Yes, everybody? X plus 2. So x plus 2 will go to 0 from the left or right? Right. Okay, we plug in x is -2. So 1 is 2 times -2. -4 minus 1. -2 plus 4. -2 minus 1. What's x plus 2 goes to? 0 plus. Right, everybody? What's -4 minus 1? -5. -2 plus 4. 2. -1 minus 2? -3. 0 plus. What do we get? Positive infinity. See? 2 negative sign is positive. Yes, everybody? Keep going. Keep going. X goes to -2 from the right. X plus 2 goes to 0 from the left. Sorry, did I say from the left or from the right? No, from the left. Yeah. Then what do you think the y goes to? Yeah, negative infinity. Very good. Okay, so yes, we have vertical asymptotes. So vertical asymptotes are those two lines. Okay, x equals 1 and x equals -2. We almost finished. Okay, so this is step 3. Keep going. Step 4. Yeah, this is long. I would say this is the longest problem we have ever seen, right, in our course. Step 4. Find the horizontal asymptotes. Remember, horizontal asymptote, we look at the biggest term. Yes, exactly. So biggest term are 2x squared and x squared. See? When x goes to infinity, y goes to, y is approximately by 2x squared over x squared. What happened to the x squared? Cancel. Do you see we get 2? How about when x goes to minus infinity? The same thing, right, everybody? So horizontal asymptote is y equals 2. Okay. Now we can plot our graph on this xy axis. So first thing, x-intercept 1/2 0. So 1/2 like here. So 1/2 0. Okay. And -4 is a negative number. So your scale do not need to be very accurate. Okay, so you don't have to put a 1, 2, 3, 4. You don't have to put 4 bar here. Okay, just put that and say this is -4, this is 1/2. And y-intercept 0, 2. So you just put a 2 here. Okay, so you put a 2 here, and that's the y-intercept. So we plot the x-intercepts and the y-intercepts. Okay, next, look at the vertical asymptotes. So we have 1. 1 is right here. You see that, everybody? 1. Vertical asymptote. You put a dashed line. So this is 1. And another one, you have what? -2. So -2 right here. So far, so good, everybody? Okay. And now, what happened? So look at this one. This means when x goes to 1 from the right, the y goes to infinity. Infinity is the top, right? So you put a small dot here. This is on the right-hand side of the line, and y goes to infinity. So right up, okay? So right up. Put a dot here. How about this guy? Left or right? Left. Up or down? Down. Left. Down. So put a point right here. Okay, put a point right here. And how about this line? This is left or right? Right. Up or down? Up. Right. Up. So put a dot up there. Yeah? How about this guy? Left or right? Left. Up or down? Down. Left, down. Put a dot right here. Is that okay, everybody? And how about horizontal asymptote? So horizontal asymptote, y equals to 2. Okay, so let me use a different line maybe. So y equals to 2 right here. That's horizontal asymptote. And we are approaching to it. So we don't know we're approaching it from the level, from the top or from the bottom. So let's put 2 dots there. Okay, we will determine which dot to use later on if which one make more sense. And then when x goes to minus infinity or infinity, the y always goes to 2. So this is when x goes to minus infinity. This is when x goes to infinity. So let's also put 2 dots right here. Okay, because we don't know which one makes more sense. After we put all the dots, let's connect the dots together. Have you played the connect the dot game? So when you were small, you connect the dot and you see an animal, maybe a dog or an octopus. Yeah, my son is doing those. He is 4 right now. Okay, we connect the dots. So my recommendation is start near the origin. Look at this part, right? Let's connect this point, and do you see? We connect this point. So we connect them. And then, do you see we connect this point and this point? Yeah. Connect them. And then, okay, look, and then keep going. Do you see this point? We need to connect this point. Okay, you tell me. We choose the top point or bottom point. Which one makes more sense to you? Bottom. Yeah. So not the top. Cross it out. Connect the bottom. And how about here? This is the point where you need to connect. The top or bottom, which one makes more sense to you? The top, exactly. So we connect the top one. Yeah, and so not the bottom one. So you can erase this point. And make sure you get a function. What is a function? Has the vertical line text. So which means you cannot intersect the vertical line multiple times. So which means, for example, so you don't want to connect this point and connect this point and connect this point. You cannot do like that. This is not a function. Okay, make sure every vertical line just intersected once. And then we finish this part. Okay. So do example 4 and